Let's just practice some more. So here, if I plug in 0, arcsine of 0, you know, is 0. And plugging in x equals 0, that gives me 0. Okay, so now I'm ready for L'Hopital's. So you know that every single time you're doing a limit, you must write limit, right? So taking the derivative of arcsine is 1 over the square root of 1 minus the angle squared times the derivative of the angle, which is 4, over the derivative of the denominator, which is just 1. So now try plugging in x equals 0. So I think it works, right? I get the number 4 over 1 minus 0, so that just gives me 4. All right, let's play with arctangent. So you know that arctangent of 0 is 0. The numerator is going to give me 0, so let's use L'Hopital. So I get 1 divided by, so derivative of arctangent is 1 plus the angle squared times the derivative of the angle, which is 3. This is pretty ugly, so I'm going to multiply by the reciprocal. So I get 1 plus 9x squared divided by 3, right? Because that 3 is like multiplied in the numerator up here. So now plug in x equals 0, so that goes away, so I just get the number 1/3. All right, what happens here? If I'm plugging in infinity, wait a minute, there's no fraction to do L'Hopital's on. This is just 4 over infinity. You know, inside the sine function, 4 over infinity, that gives me 0, so I'm looking at sine of 0. That's just 0, right? Okay. So just making sure you remember everything about limits because it's been quite some time. Now if I'm plugging in infinity, I have 3 times infinity divided by 2. All of that is infinity. Cosine of infinity, wait a minute, cosine goes forever as x's are going to infinity. Cosine is forever rotating, or oscillating, I should say, oscillating between 1 and -1. This limit does not exist. How about this one? Putting in infinity up in the exponent. 3 over infinity, that would give me a 0. And e to the 0, that just gives me a 1. So just playing with other limits, that just making sure that you know what you know. All right, so here we go. Putting in infinity, I get infinity over infinity. So limit as x goes to infinity, L'Hopital's 1 over x over 1. So now put in infinity, 1 over infinity, that gives me 0. A little tricky here. So if I'm looking at the graph of 3 over x, you know that looks something like this, right? So this is saying x is going to 0 from the negative side. That means coming in from this way, right? So if x is going into 0 from the negative side of 3 over x, that looks like it's going down to negative infinity. So it's going to negative infinity. So then I've got e to the negative infinity, right? Because that's where this expression is. E to the negative infinity gives me 0, because 1 over e to the infinity gives me 0. So there's going to be times we need to think about things. So this is a good one to think about. All right, limit as x goes to infinity of ln of 4x. That's ln of infinity. That's just infinity. So I really want to make sure that you're comfortable with lots of different kinds of limits. That's why I did lots of examples.